Hello everyone. In this video tutorial, we are going to discuss one numerical, the procedure to solve numerical, which will be based on eccentrically loaded voltage joint in shear. This today's discussion or this video tutorial will belong to course outcome number 5, wherein after studying this unit, the students will be able to design threaded and welded joints subjected to eccentric loads like jeep-headed cranes. Now, we have already studied that there can be four different types of numericals which can be based on the threaded joints consideration. While designing the threaded joints, that means deciding the dimensions of the boards for threaded joints, there can be four different type of numericals. Those can be asked in your examination. The first type is the numericals wherein eccentrically loaded bolted joints are required to be designed where the load will causing shearing of the bolts. Then second type will be eccentrically loaded bolted joints wherein the eccentric load is perpendicular to the axis of the bolt. Third type is eccentrically loaded bolted joint wherein the eccentric load is parallel to the axis of the bolt. And the fourth type is bolted joint subjected to tensile loads. Of which first type, that bolted joint subjected to eccentric load, the nature of the load is shearing one. The very first type, we are starting our discussion regarding this type number 1 by solving one numerical. Now, as shown here in this figure, one can note that a plate or a bracket is clamped with a support using say 4 number of bolts or Z number of bolts, and the plate is or the bracket is subjected to external load W. This load, externally load applied W, will cause shearing of the bolts. This externally applied force is called as eccentric force because the line of action of the force is not passing through the CG of the bolted system. By mere inspection due to symmetry, one can identify or one can locate the CG, and line of action of the applied force is not passing through the CG, rather it is eccentric by eccentricity E. Therefore, it is case of eccentrically loaded bolted joint in shear. Now, we have studied there are primary and the secondary forces. Primary forces are given by W upon Z, where Z is the number of bolts. Secondary forces are given by C into L1, L2, etc. for calculating secondary force for bolt number 1, bolt number 2, etc. Then both the primary and the secondary forces are of shearing nature, and for finding out the resultant, we have to perform vector sum of primary and secondary force. Theta is the angle between primary and secondary force. Then the resultant is given by resultant Fr is given by root of Fp square plus Fs square plus 2 times Fp Fs cos of theta. Then we have to identify the critically loaded bolt for which resultant will be maximum. For that, we can apply the logic such that the furthermost bolts are critically loaded, and uh, the bolt having lesser value of theta, where theta is the angle between primary and the secondary force, the bolt having lesser value of theta will be having more value of Fr. So applying this logic, the bolt which is furthermost from the CG and the bolt having lesser value of theta will be the critically loaded bolt. And using this logic, not calculating Fr for all the bolts, rather applying the logic we can directly predict which board will be critically loaded board and FR max will be experienced by which board, because we have to find out a resultant force for the critically loaded board, and that resultant force FR max is to be taken into account for further analysis. FR max divided by core cross section area of the board will give you the induced maximum shear stress. This will be equated with permissible shear stress. While equating induced maximum shear stress with permissible stress, Fr max upon AC is equated with tau permissible. While equating AC is the only unknown, so you will be in position to calculate AC. AC is the core area, core cross section area, but AC is given by pi by 4 DC square. So you will be in position to calculate DC, the core diameter. Once we know the core diameter is divided by 0.84 or multiplied by 1.19, so as to find out nominal diameter of the board required for that particular assembly. The next standard value, M value, will be specified as the size of the board selected for that particular assembly. So this is the general procedure to be followed while solving numericals based on eccentrically loaded bolted joints in shear. Now let us solve one numerical based on this concept of eccentrically loaded bolted joint in shear. Here one bracket is shown which is attached with the support using 6 number of bolts. What is specified, equispaced 6 bolts on PCD of 280. If we consider an imaginary circle upon which these 6 bolts are equispaced, then that imaginary circle will have diameter of 280. Then the bolts are equispaced, bolts are symmetric, therefore by mere inspection also we can predict or we can locate the CG which will be at the center of this imaginary circle upon which the bolts are situated. Now the value of distance L1, L2, etc. L1, L2, etc. are the distances between the center of the board and CG. So here in this particular case, the distances L1, L2, etc. will be radius of this imaginary circle, radius of this pitch circle. So L1, L2, etc. values will be equal to 140. Now here they are specified that externally applied load W is 9870 Newton. Eccentricity is the perpendicular distance between line of action of the force and CG. In this case, that has been directly specified as 470. Generally, SYT value is specified. SYT is the yield strength, but in this particular case, SSY, the shear strength, is directly specified to be equal to 263. Dividing value of SSY by factor of safety. Factor of safety is being specified as 3.2. Dividing SSY by factor of safety, we can calculate, we can predict what will be the tau permissible. Tau permissible is required later on, but here at this stage only we have just calculated value of tau permissible, which is equal to 82.18. Now, as we know, the bolts are subjected to primary and secondary shear forces, of which primary shear force is given by Fp is equal to W upon Z, where Z is the number of bolts. In this case, Z, the number of bolts, is equal to 6. Therefore, primary force, which will be same at each and every bolt, Fp1 will be same as Fp2, Fp3, and up to Fp6. All these values will be same, and those values will be given by W upon Z. Here Z is equal to 6. W is the externally applied load. In this particular case, that is 9870. So 9870 divided by 6. So 1645 Newton is the value of primary force. As far as direction of primary force is concerned, direction of primary force is always opposite to the direction of applied load. So the direction of primary force will be in upward sense, because externally applied load is getting applied in downward sense. As far as the secondary shear stress Fs is concerned, Fs will be calculated as C times L, where L is the distance between the center of the board and the CG. As we have already discussed, for all the 6 boards, this distance L1, L2, etc. is given by radius of the imaginary pitch circle, and that in this particular case that value is 140. Therefore L1, L2, etc. values are equal to 140. Now the constant C is calculated as W into E divided by L1 square plus L2 square plus L3 square up to L6 square, because 6 number of boards are present in the assembly. So here W is the 9870, eccentricity 470, and 6 times L1 square, because L1, L2, L3, L4, L5 and L6 are having same magnitude of 140. Therefore 6 times 140 square. So value of C will be given by 39.44, and unit for C will be Newton per millimeter. Multiplying value of C by distances L1, L2, etc., we can calculate secondary forces. In this case, value of L1, L2, etc. is same. Therefore, secondary force for each and every of the 6 boards will be same. Therefore, Fs1, Fs2, Fs3, etc. will be same, that given by C into L. And in this particular case, that value is equal to 55,522.5 Newton. Now to decide the directions, here we have to apply the logic for the primary force. Primary force is acting opposite to the direction of applied force. Applied force is in downward direction. Therefore, the pink colored primary forces shown in upward direction, those will be in upward sense, because external applied load is in downward sense. Now, as far as the secondary forces are concerned, secondary forces will try to rotate the plate or the bracket in opposite sense to the sense of rotation caused due to externally applied load. Now here one can see that externally applied load will cause clockwise rotation of the bracket. So secondary force is to be considered in opposite sense. That means secondary force should be in such a direction as to cause rotation of the bracket in anti-clockwise sense. Externally applied load causes rotation of the bracket in clockwise sense. It will apply moment or torque equal to W into E, and it will try to rotate the bracket in clockwise sense. So secondary force should be applied in will get applied in such a direction as to cause anti-clockwise rotation of the bracket. So here the green colored arrows are shown, which represent secondary forces and which show or which cause the anti-clockwise rotation of the bracket, because externally applied load causes clockwise rotation and secondary force should cause opposite anti-clockwise rotation of the bracket. Therefore secondary forces will be in direction as shown by these green arrows. Now here, due to symmetry, value of Fp1, value of primary and secondary forces will be same. Therefore critically loaded board will be decided based on the consideration of value theta. There are two considerations to decide the critically loaded board. The board which one is furthermost and which one is having lesser value of theta. In this case, all the boards are situated at same distance of 140 millimeter from the CG. Therefore, first logic cannot be applied. So here we have to apply the second logic, that the board having lesser value of theta will be critically loaded and which will experience maximum amount of resultant shear force. So here by our visual inspection we can say that value of theta is smaller for either board number 2 or 3 as compared to rest of the boards. So either of board number 2 or 3 will be considered as critically loaded board. These two boards are having same value of theta, same value of FP and same value of FR. Therefore, either of the board will be considered as critically loaded board, say board number 2, and the magnitude of the resultant force as experienced by this board will be taken into account for further analysis. So here we need to calculate FR2 because we are considering board number 2 to be critically loaded board, and the resultant force as experienced by board number 2 FR2 will be taken into account for further analysis. Now, for analysis, for calculating FR at board number 2, we are in need of value of theta 2. Theta 2 is the angle between primary and secondary force. Up till now, we have calculated primary force FP2. We have also calculated secondary force FS2, but yet we have not calculated theta 2. For calculating value of theta 2, we know that angle subtended at point G by the line joining both center of the board with the G will subtend same angle. Theta 2 is the angle as subtended by line joining board center with the center of gravity. This angle will be theta 2. Now, if we consider board number 2 and 3, the angle between these two lines will be 60 because due to construction, as these boards are situated a, along an imaginary circle and they are equispaced, therefore angle between any of the consecutive two boards will be 60 degrees. So say board number 2 and board number 3 will subtend angle of 60 degrees at the center. Therefore, angle theta 2 as subtended by board number 2 with G will be equal to 30 degrees, and that will be the same as the angle theta 2 subtended between primary and the secondary force. So here angle theta 2 will be 30 degrees, and we have already calculated Fs2 as equal to 5522.5. Also we have calculated Fp2 as 1645 Newton. So we are now in position to calculate resultant force as experienced by board number 2 using this relation. Here Fp2, Fs2 and theta 2, all the values are known to us. Therefore, we are in position to calculate FR2. By mistake, I have written FR1. It should be FR2. So FR2 is 6995.63. This FR2 when divided by AC, the core cross section area, that will represent maximum induced stress in board number 2. That is to be equated with tau permissible. Tau permissible is already calculated in the previous slide. Tau permissible is already calculated as 82.18. So we are now in position to equate tau max with tau permissible. While equating tau max with tau permissible is 82.18 and tau max is 6995.63 divided by AC. AC is the core cross-sectional diameter. So while equating tau max with tau permissible, AC is the only unknown. Value of AC is calculated as 85.12. But AC is equal to pi by 4 DC square. Therefore, one can calculate DC value of core diameter, which happens to be equal to 10.41 millimeters. Multiplying DC by 1.19 or dividing DC by 0.84, one can calculate D, the nominal diameter of the board required for this particular assembly. So in this case, it is 12.39. Therefore, next standard value is selected, and considering that for this particular assembly, one has to select M14 boards, standard metric boards next to value of D is equal to 12.39 is 14. Therefore, M14 bolts are selected for this particular assembly as specified in the problem statement. In this video tutorial, we have studied what are the threaded joints, four type of threaded joints, how to find out primary and secondary forces, how to find out resultant of primary and secondary forces, and how to design eccentrically loaded bolted joint in shear. So that's all as far as this particular video tutorial is concerned. Thank you.